Today we're going to discuss section 11.2. It's exponential functions. Basically, an exponential function is any function that has a variable in an exponent position. So 2 to the x power is considered an exponential function. We have heard a lot about exponential functions in the news because basically if they are to graph the track of the coronavirus, it is an exponential growth. If I were to graph this particular equation, I would do it by plotting in values for the x. So when x is equal to 0, my y is equal to 1, because remember, anything to the 0 power is equal to 1. If x is equal to 1, and I put the x right there, then y is equal to 2. When x is equal to 2, y is equal to 4. So you can see that it quickly travels up. That's why it's been like the track of the coronavirus. You will never be able to go, y is never going to be a negative number here, because there is no value that I can plug in there for x that is going to make my y negative. Because if I put, like, let's say I put a negative 1 in there. Remember, negative 1 simply means that I put it underneath a 1. I put it in the opposite position. So at negative 1, y is going to equal 1/2. If I put a negative 2 there, y would equal 1/4. And you can see it gets closer and closer to 0, but it never crosses over that line, okay? One thing you're going to be doing in this section, this is not a big section with a lot of new information, but you're going to be graphing these things, and you can think of parent graph issues with this as well. Let's say I start out with that particular equation. Again, if x is equal to 0, y is going to equal 1. But this time, if x is equal to 1, I'm going to go a little bit steeper. And when x is equal to 2, I'm up here at like 16. So, and remember, it's not going to cross there because it's just going to get closer and closer to 0. So I have that. But if I turned around and I said, well, what if I graph y equals 4x plus 1? Well, what happens, just like with our parent graph, that 1 is going to move everything up. So it's going to move that whole graph up 1. If I were to subtract 3, it would move it down 3. Because then it will go underneath that, because I will be subtracting 3 from any number I have, so I could possibly get a negative number. Exponential functions are found in word problems, and that's where we're going to focus in on them today. Mostly finance. A lot of financial problems have exponential functions in them, and a lot of like growth and decay problems, like science problems, have exponential functions in them. Basically today a lot is just going to be financial. I think some of your word problems might be more growth and decay. Okay, if you look at your book on page 707, there's a finance problem. It says determine the amount of money in a money market providing an annual rate of 5% compounded daily if Marcus invested $2,000 and left it in the account for 7 years. Okay, so you know it used to be all the time, not so much anymore, but when a bank would use your money, they would pay you an interest rate. And you can have an interest rate that is compounded daily, or you could have, and that meant that they would add the amount you got in interest each day, and then you would get interest on that interest because it would be added in. Well, in this particular problem, it says it's compounded daily. So they suggest that we use this particular equation, and then later on we're going to learn in a different section how to use another equation. But the equation looks like this that we're going to use. You can see that you have variables up here in your exponent. This is how much money after a particular investment of P amount of dollars. In this particular case, P is equal to 2,000. He's investing $2,000 at a rate of 5% for a time of 7 years. Now the N here is the number of times interest is added. And this particular problem says it's continuous. Well, if it's continuous, then there's 365 days a year, so the N is going to be 365. So I'm going to say the amount I earn is 2,000 times 1 plus, now I have to take the percent and make it into a decimal 0.5 over 365, because I'm taking the interest daily and adding it back to the principal, raised to the 365 times 7 power. Now, be careful of your parentheses, but you should be able to do this all in one shot. On your calculator, if you put the parentheses in there in the right location. And you should come up with $2,838.07. Now remember, it's going to have to be rounded to 2 places after the decimal, because you're talking about money. So basically, if you invested $2,000 into this bank that's going to pay you 5%, and it's going to compound the interest daily, in other words, it's going to add the interest back in every day and then get interest on that interest, and you left it in there for 7 years, your $2,000 will become $2,838.07. All right, let's do another one. I'm going to have you do this one by yourself, okay, and then come back to the video and check it, okay, and as it's a word problem, so I'll talk you through this information over here so you get it down, but then you're going to have to put it into this same formula. And it says, how much should Sabrina invest now in a money market account if she wishes to have, so what she wants annually is $9,000. She doesn't know what that is, okay? She's going to leave it in the account for 10 years. The rate is going to be 6%. And it's compounded quarterly. Now, quarterly would mean 4 times in a year. Okay, semi-annually is going to be twice in a year. Quarterly is going to be 4 times a year. Annually would just be once a year. And of course, daily is 365 days. So, work this problem out and then come back to the video. All right, your 9,000 goes right here. I don't know what the P is, I'll leave that blank. So I have 1 plus, the rate is 0.06, divided by 4, because it's quarterly, raised to the 4 times 10 power. This right here is 1.015 raised to the 40th power. And if I do that out, that's going to give me 1.8140. Well, I want the P by itself, so I'm going to divide both sides by the 1.8140. And I'm going to find out that I should invest $4,961.36. That's the answer that you should have gotten when you plugged it in. The only other thing in this particular section is you're going to graph some exponential functions. So let's say I wanted to graph this. Again, you're going to plug in. Okay, if x is equal to 0, then I have, this is going to be 1 plus 1, so I have a 2. If x is equal to 1, then I have a 2 plus 1, or a 3. My 0 line is going to move up 1 because it's plus 1, so it's never going to cross that line. Okay, and I could go on and do another point if I wanted to. And it says it's below this line, and this line should be dotted because it's less than So everything down here is shaded in. So you've done stuff like this before, it's just a matter of putting your variable up in your exponent. Alright, your homework for this, like I said, there's not a whole lot to this section, is page 708 through 709, 10 through 20 even, and then 24B, 28, and 29. Okay?